So our Math 2 Unit 12b review. We start with stating the characteristics each equation reveals without changing the form of the equation. So we need to match A, B, and C over to these equations. First one I notice is the zeros x-intercepts. This is going to show up when it's in the factored form. So that goes right here for B. Left here I have vertex form and I have standard form. You can easily find the vertex or the maximum value in the vertex form. So we're going to put an A there. And then last reveals what you get if you make the x's 0. That's a really easy one to find the y-intercept, and that will be the last one, C, right there. Okay, next equation, circle the letter of the equations that have no real solution. So I'm going to factor it and see if what I get. If they're factorable, that works. Irrationals, rationals, either one in the case. So we look here, x squared minus 10x plus 8. I cannot factor x squared minus 10x plus 8, so we're going to look at quadratic formula. So that's going to be a negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times 8 over 2 times 1. And that is, again, our quadratic formula. So this comes out to have a 2 on the bottom, 10 out in front, and I have 100 minus 32. So we're going to get 10 plus or minus the square root of, that would be 68 over 2. 68 is going to simplify. It's going to give us an irrational number. That is 2 root 17. So now we reduce and we get 5 plus or minus root 17, which is a real solution. It is irrational, but it works. X equals 5 plus or minus root 17. So it does have real solutions. We're good there. The next one, 3x squared plus 12x minus 18. I'm going to factor a 3 out of all of those. I'm left with x squared plus 4x minus 6 equals 0. X squared plus 4x minus 6 after I divide the 3. I can't factor, multiplies to negative 6, that adds to 4, so quadratic formula again. So we have negative 4 plus or minus 4 squared minus 4 times 1 times negative 6 over 2 times 1. Negative 4 and 2 there. Inside the radical we get 16 plus 24, which is 40. 40 is going to come out to be 2 root 10. So we're going to get answers of negative 2 plus or minus root 10, which is also a real solution. Irrational, but it's still a real solution. C. We have x squared plus 4x plus 21. Can't multiply to 21. That adds to 4x, or adds to 4. So quadratic formula again. Negative 4 plus or minus 4 squared minus 4 times 1 times 21 for 2 times 1. We get a 16 minus 84 here, which 16 minus 84 is negative 68. And this is where we have a problem here, because negative 68 gives us an imaginary solution. If we simplify this further, 68, like we said earlier, is 2 root 17. The negative comes out as an I, and so it's 2i root 17 over 2. Then divide by 2, and we get this answer. So that is our answer up here on C. And it's imaginary, so it has no real solutions, so we'll circle that, and that is the answer. Now before we go further, let's look at what's happening here. The first two were real solutions. And if you look, their square roots, 68 and 40, as we got to them, were positive, so we'd end up with an irrational solution, so it'd still have real solutions. This one, though, over here had a negative. So whatever we get inside the square root, if it turns out to be a negative value, whenever we have to take the square root, it's in fact going to become no real solutions. It's only going to have imaginary solutions. If they're positive, or if it's just 0 and the square root's gone, then they're going to get real solutions. This is something we call the determinant, which helps us figure out how many real solutions there are. So let's take that idea and now look at x squared minus 36. This one we can solve without quadratic formula. X squared minus 36, if I add over the 36, I get x squared equals 36. Square root of both sides, I get plus or minus 6 as my solutions. Those are real, so those work. X squared plus 4, if we subtract the 4 over, and we take the square root of both sides, we have plus or minus the square root of negative 4, which is imaginary. So the negative 1 comes out, makes it an I, and the square root of 4 is 2, so our answer is plus or minus 2I, which is imaginary. Now for f, multiplies to negative 7, that adds to negative 6. I'm looking at that. 7 and 1 come to mind. If it was a negative 7, positive 1, those would add to negative 6 and multiply. So we're going to go x minus 7, x plus 1 equals 0. And then our solutions are 7 and negative 1. Also real solutions. So it turns out that E and C are the imaginary solutions. And again, looking at that square root, getting a negative, it shows when the imaginary solutions come up. Okay, now on to 3a. What value are we going to fill in to make it a perfect square trinomial? This applies to complete the square. We take half of b, half of 10, and square it. So that's going to be 5 squared, so that is 25. So we're going to have c equal to 25. Because in doing so, it would then become x squared, or x plus 5 quantity squared. For number b, or letter b, we're going to take negative 18, half of that squared, we get negative 9 squared, which is 81. Put that back in, this would then factor to be x minus 9 quantity squared. So c needs to be 81. For number 4, the 6 parts, we are simplifying our complex numbers. For 4a, we're going to do distributive property. I get 6i squared minus 12i. And the important thing we need to remember is anytime we get I squared, that is equal to negative 1. So this now becomes 6 times negative 1 minus 12i, or negative 6 minus 12i. For b, we're going to multiply. I prefer to multiply using box. It's 2 minus 5i, 3 minus 7i. We get 6 minus 15i minus 14i plus 35i squared. So writing this out, it's 6. Then we have negative 14, negative 15 is negative 29i, and then a plus 35i squared. Now I squared is negative 1. So we got negative 35 here now, and negative 35 and 6 is negative 29. So it's negative 29 minus 29i. For c, we need to fix the imaginary number in the denominator. We can't do that. So we're going to multiply the top and the bottom by I. And even though it's a 3i on the bottom, multiplying top and bottom by I is enough. We get 5i minus 2i squared over 3i squared. Using the fact that I squared is negative 1, we get 5i plus 2 and a negative 3 in the denominator. Now we need to split this into 2 fractions. We do the real part first, which is 2 over negative 3, or negative 2/3. And the imaginary part last, which is 5i over negative 3, so we write minus 5i over 3. For part D, we're going to do distributive property again. We get 5i squared plus 20i. I squared becomes negative 1, so this is now negative 5 plus 20i. For E, we're going to multiply. We'll use the box again. This is a binomial idea times a binomial. That's 8, 18i, negative 4i, and negative 9i squared. So 18i and negative 4i is 14i, and the negative 9i squared on the end. This becomes a positive 9 because it's I squared. Now 8 and 9 is 17, so we go 17 plus 14i. Last one in the set here is 7i in the denominator, so we multiply top and the bottom by I. We get 4i plus 3i squared over 7i squared. The I squareds become negative 1, so that's 4i minus 3, and negative 7i. Our real solution is negative 3 over negative 7, which is 3/7. Our imaginary is 4i over negative 7, so that's minus 4i over 7. Now for number 5, we're going to be doing completing the square. So it's asking what do we fill in the blanks. I'm going to work this one off to the side and see what I get, and I'll fill my answer. So x squared minus 4x, I'm going to add the 5 over to the other side. Then I'm going to take half of negative 4 squared. So half of negative 4 is negative 2. Square that is positive 4. I add that to both sides, which then allows this left side to factor, and the right side is 9, which is kind of what they're asking for. So it's x minus, but I have x minus 2 here, so I'm just going to put a 2 right there. So it's x minus 2, 2 there. And then the right-hand side happened to be 9. Put a 9 there. Now they want us to finish solving the problem. So now take the square root of both sides, and I get plus or minus the square root of 9, which gives me plus or minus 3. We then add the 2 over. 2 plus or minus 3 tells us our answers are 2 plus 3, which is 5, and 2 minus 3, which is negative 1. So we say 5 and negative 1. Number 6 does the same idea. I'm going to start it off with x squared minus 16x equals a 17 to the other side. We're going to take half of 16 and square it. That's negative 8 squared is a 64. So that goes to both sides. The left-hand side becomes x minus 8 squared. The right-hand side is 81. We then take the square root of both sides. So we got ahead of ourselves. We're going to fill them in. It's going to be x minus 8 here and 81. Notice the minus. So we're x minus 8. So we put 8 and 81 there. Now the square root of this, plus or minus the square root of 81, that happens to be 9. So x minus 8 equals plus or minus 9. That becomes 8 plus or minus 9. 8 plus 9 is 17. 8 minus 9 is negative 1. So it's negative 1 and positive 17. For number 7, we need to find the vertex of our parabola. Whenever this is in standard form, x equals negative b over 2a is the way we find our line of symmetry or axis of symmetry. This is the most important thing you need to remember for this process. So this becomes negative 6 over 2 times 1. Negative 6 over 2 gives us a negative 3. That is our line of symmetry. We now plug negative 3 back into the equation, so f of negative 3 to get our y value. We get 9 minus 18 plus 11. 9 and 11 is 20, minus 18 is 2. So your vertex comes out to be negative 3, 2. Number 8 is the same idea. X equals negative b over 2a. We're going to do negative negative 2 over 2 times 1. That's going to be 2 over 2, or 1. We now plug this back into the equation. F of 1 equals 1 squared minus 2 times 1 minus 5. These two negatives together become a negative 7. Out of 1, I get negative 6. So my vertex would be 1, negative 6. For number 9, we need to determine the equivalent function of this one in vertex form. And to do this, we're going to complete the square. So let's write it down here and see what we have. I have x squared minus 10x plus 1. So I'm going to put this in parentheses, and I'm going to complete the square here. So we have x squared minus 10x. I'm going to take half of negative 10, which is negative 5. Squared is 25. But if I add it to this side, to keep things balanced, I also have to subtract it from this side. So really it's like I'm adding 0, just adding 25, subtracting 25, which comes out to be 0. In doing that, this parentheses, this quantity here, factors to be x minus 5, quantity squared, minus 24. So this is how we get to vertex form. We complete the square. We say f of x equals x minus 5 squared minus 24. We'll do the same thing again for number 10. So we have f of x equals x squared minus 2x, with the minus 5 on the end. Half of negative 2 is negative 1. Squared is positive 1. If I added it to this side, I need to subtract it to the same side. So this becomes x minus 1 squared minus 6. So we get this in vertex form. Number 11, we're going to graph these two functions we have and find the solutions. So first we have x squared minus 9. So it looks like our graph actually goes off here. So it would be right there is 0, negative 9. And it's an x squared, so it opens up. I know the first step is 1 unit on either side. And I know it would then graph up. Maybe to give me another point of reference here, why don't we find the solutions of x squared minus 9? So f of x equals x squared minus 9 also factors to be x minus 3, x plus 3. So if that's the case, I know it hits on either side right here. So now I can kind of sketch through those 2 points. Just another point of reference for us. So that is f of x. Okay, g of x is x minus 3. X minus 3 is a line. The y-intercept is negative 3. And the slope is 1. So it is going to go up and over 1 unit. And we're going to go this way as well. So it looks like we have x equals 3 as one of our solutions. So they both meet at 0 there. The other one we got to find, it looks like down here at negative 2, they do meet. We should check though. So let's check for both of them just to make sure. So f of negative 2 gives us negative 2 squared minus 9, which is 4 minus 9, or negative 5. G of negative 2 is negative 2 minus 3, which is also negative 5. So the fact they both have the same y value at negative 2 also tells us that's a solution. So we're going to say that the solutions are when x equals 3 and x equals negative 2. The other way you could show this is by solving algebraically. So what I'm going to do is take both of these and set them equal to each other. We got x squared minus 9 equals x minus 3. If we subtract over an x, we're here. We're then going to add 3. So we have x squared minus x minus 6 equals 0. This factors to be x minus 3, x plus 2, which then if you set both of them equal to 0, you get x equals 3 and x equals negative 2, which were the same solutions. Now for this set, we need to identify the table of values as either being linear, quadratic, or exponential. So let's go through and first look at the differences in how they change. First off, from negative 9 to 4, we added 5. Negative 4 to 1, we added 5. 1 to 6 is 5, and 5 there. So it looks like we're adding 5 each time. Anytime we add a constant value each time, that we're going to define as a linear. That is also by saying your slope would be 5 in this graph. If we go to B, went up 8, went up 24, went up a lot more. So this one, it actually looks like it's multiplying each time. So if I multiplied 4 by 3, I get 12. 12 times 3 is 36. 36 times 3 is 108. Another way you could check that is divide values, divide a term by its previous term, and see if it comes out to be its multiplier. So something like 12 over 4 gives us 3. 36 over 12 also gives us 3. 324 divided by 108 also gives us 3. So it's always a constant multiplier that we have. So this is going to be your exponential. Okay, last one, I added 7, then I added 5, then 3, then 1. Well, this is kind of not the same, and not like they're multiplying. They kind of go down each time they add. So it's actually the amount that it changes, this kind of second level, if it changes, is what's happening. And this is what happens in a quadratic. So we have our linear is a constant change, exponent is a constant multiplier, and quadratic is that second level of common change. They all change, but they change a constant amount each time. Okay, number 13, we need to state the solutions. Looking at my graph, it looks like -3 and 2 are where the two graphs meet. So we'd say x equals -3 and x equals 2. For B, I see at -3 and 2, we also have solutions. For 14, we need to solve for x and leave it in radical form. We could do quadratic formula, we could do complete the square. Let's do complete the square on this one. So I get x squared minus 4x equals -1. I'm then going to do x squared minus 4x plus 4, because that's half of -4 squared. And I'm going to add that to both sides. The left side then becomes x minus 2 quantity squared equals 3. By then taking the square root of both sides, we get x minus 2 equals plus or minus root 3. And then we add 2 over 2 plus or minus root 3 to get to our solution. Quadratic formula should get you to this same answer. If we look at 15, we'll do quadratic formula for this one, because we did complete the square on the last. We get -4 plus or minus. It's going to be 4 squared minus 4 times 1 times 7 over 2 times 1. We then have -4 and a 2 there. Inside the radical, it's 16 minus 28, which we come over here. -4 plus or minus, that is a -12 over 2. We could simplify the square root of -12. We know it's imaginary, so an I comes out. 12 is also 4 times 3, therefore it becomes 2 root 3. And then lastly, we can reduce the 2, the 4, and the 2. They all divide, so we get -2 plus or minus I root 3. Now for number 16, we're simplifying our square roots. The square root of -4 is like saying -1 times 4. The -1 becomes an I. The square root of 4 is 2, so our answer is 2I. For B, 18, square root of 1 times 18, but also it's this -1 times 9 times 2. Square root of 9 is 3. -1 gives us an I. We're left with 2 left there. 3I root 2. For C, 11, you're not going to be able to simplify, so you're going to leave that in the radical, but the I comes out, so we say I root 11. For D, I times I is I squared, and I squared, we've talked earlier, is just -1. For E, we get 2, square root of 4. For F, it's going to be -1 times 25 times 2. And I bring that up because 25 is a perfect square. It comes out as a 5. The -1 is an I, so we're left with root 2, 5I root 2. For G, -9 is going to become an I on the outside, and the square root of 9 is 3, or just 3I. And H is our last one, the square root of -1, we just call I. For 17, we're going to plug in our parts to quadratic formula and then solve from there. So first term is -b. That's going to be a -5. B squared, that's also a -5, minus 4, just the constant. AC, 3, -1, over 2 times A, which is 3. So now to solve, it's going to be 5 plus or minus 25. This is minus minus, so it's going to be a plus 12 over 6, which is now 5 plus or minus the square root of 37 over 6. 37 is not going to simplify as a radical, so we're going to write 5 over 6 plus or minus root 37 over 6. Or you could write it in this form. For number 18, which equation best fits the model of the graph? So if I drew a line of best fit, kind of guessed through this, it looks like it's going to be a linear line. So looking linear, I know this one is out and this one is out because it is not quadratic, or it's quadratic and exponential. Between these two, I'm going to go with B because this is a negative slope, meaning it would be going down, and that slope is increasing. For part B, we're looking at it, we have, looks like a quadratic, so we want to take the one that has an x squared, which eliminates B and D. Between these two, we take the positive 2x squared plus 1 as opposed to the negative, because the negative would be opening down, and this one's clearly not doing that. Our answer would be C. Last problem, number 19, we need to identify the axis of symmetry, the vertex, and the solutions. Axis of symmetry we'll start with first. That is negative b over 2a. So we're going to go negative 100 over 2 times negative 16, which gives us 100 over 32. Now 100 over 32 comes out to be 25 over 8. So we could say that x equals 25 over 8. If it asks for as a decimal, that is 3.125. We're going to leave it as a fraction for right now. We're going to then plug that back into the equation. And we're going to say f of 25 over 8 equals negative 16 times 25 over 8 squared plus 100 times 25 over 8 plus 84. So now we have negative 16, 25 squared is 625, and 8 squared is 64. 25 times 100 is 2500 over 8 plus 84. Looking here, I can divide 64 by 16, which makes this into a 4. So this is negative 625 over 4. I can also divide this one to become 1250 over 4. Now, I want to get common denominators. So what we'll do from here is we're going to keep it as negative 625 over 4 plus 1250 over 4. And then we're going to make 84. If I multiply it by 4, it's 336 over 4. So now we're going to go 1250 plus 336 minus 625 gives us 961 over 4, which is about 240.25. So our vertex, we're just going to write as a fraction. It is 25 over 8, comma 961 over 4. So that's to get vertex. Not very nice numbers, but we can at least work our way through it. Solutions, we could come up here and we're going to solve. First thing I'm going to do is divide everything by 4. So I get negative 4x squared plus 25x plus 21. I could now factor this, or I could look at using quadratic formula. Once we square 25, we get 625. 4 times 4 times 21 is 336. That is addition because we have two negatives here. So then we get negative 25 plus or minus the square root of 961 over negative 8. For 961, that is a perfect square. That is the perfect square of 31. So now we have negative 25 plus 31 over negative 8. And negative 25 minus 31 over negative 8. The bottom one becomes negative 56 over negative 8, which is just 7, because it's negative divided by a negative. And up here we get 6 over negative 8, which comes out to be negative 3/4. So our two solutions are negative 3/4 and 7. So up here we'd write x equals 7 and negative 3/4. These are the solutions, whereas we found the vertex to begin with.